Welcome to lesson 7121, circular arc length. Now we're going to be looking at the circumference of a circle. Okay, so arc length formula is in radian measure, if it's in radian measure. Now, we're going to be going back and forth between radian degrees, but once we get deep into this, we're going to be in radians only. So let us understand this equation stands for radian measure. So this is our equation. Arc length equals the radius times the angle. Okay, perimeter of a pizza slice. So perimeter is called circumference when we're dealing with circles. Find the perimeter of a 60-degree slice of a large 7-inch radius pizza. Okay, so we were given S equals R times theta. So the arc length equals R, which is 7. But that was for radian measure. So this is degree measure. So we need to do 60 times pi over 180, which gives us 7 pi over 3. And depending on how the program wants it, this is called an exact number. You have no loose decimals. You haven't, because pi is an irrational number, it goes on forever. This is an exact number. We don't have to round or any of that. If your program, if you're doing some kind of computer program or your teacher wants decimals rounded to something degree, what you're going to do is hit alpha on your TI-84 or your Calculate 84 on your phone, xt, theta n. You put 7, and to do pi is second and caret. This key is over the division symbol. Anytime I put something in a box, these are keys, buttons you push. Put it over 3. You got to hit the down arrow to get below the fraction bar. Then hit enter, and you will get a decimal equivalent of this angle. Not angle, sector length. I'm sorry, sector length. Okay, let's look at this problem. The running lanes at Emory Sears Track at Bluffton College are 1 meter wide. Let's see if that's useful. We have a number. We're going to highlight it. The inside radius of lane 1 is 33 meters. The inside radius of lane 2 is 34 meters. How much longer is lane 2 than lane 1 around one turn? Okay, so basically you have a running track. And this is lane 1. And then lane 2 comes along. So if you're running track, I should probably put the inner and the color. So if you're running track, and we know tracks are like oval-shaped things, and you have your running lanes, and that shouldn't have touched, but okay, so this radius is 33, and this radius is 34. So how much longer is lane 2 than lane 1 around one turn? Okay, what we need to understand is that pi radians, if we convert it to degrees, we get 180 over pi. So that equals 180 degrees. So pi radians equals 180 degrees. If we look at the turn, what we have here is 2 complete semicircles. So if we use S equals R theta, then theta equals pi. Our angle is 180 degrees. Okay? So now, we know that S equals R times theta to give us an arc length. Theta is 180 degrees, which equals R times pi. So what I'm going to do is do 34 pi, one circle, minus another circle, and that gives us pi. So the actual length of lane 2 is pi meters longer than running around a semicircle in lane 1. Now go do some practice problems.